Hello everyone. So today I'm going to be guiding you through a brand new feature that I'm really excited about within our Phoretix 1D version 1.4, which is the ability to import native .scn files from Bio-Rad imaging equipment. So if you are currently using Bio-Rad ChemiDoc or another scanning piece of equipment from Bio-Rad, you'll know that they export typically in a .scn file format, which was somewhat proprietary to ImageLab, meaning you were kind of stuck using ImageLab if you wanted to use your raw export and not convert your files. Now within Phoretix 1D, we could always work with .tiff files, but now we can actually import the .scn files natively. So if your lab's got folders full of .scn files, but you want to try out Phoretix 1D because of the advanced features we've got within our software, that blocker is now no longer there. You can simply bring them in, analyze them and compare them to what you were getting with ImageLab, and do all of the normal features and functions you would expect from a modern piece of 1D image analysis software. So you can either drag your SCN files straight into the program, or you can use the file browser menu from here. So if we open up the file browser, come to our options and just show all files, you can see that now we can open these .scn files. So if I just grab one of these, or you can see here that just opened completely natively. We've not lost any of the data that was within the file. We still respect the metadata within the file, so we can still read the metadata from the file and represent all these positions in millimeters. We're still at 16 bits per pixel image quality resolution within this image. Nothing has been lost, but now we're able to benefit from all the additional tools that we've got within Phoretix 1D as we would normally if we were just using a TIFF image. So those kind of benefits I'm talking about is obviously our automated lane detection. We've got our background subtraction methods, and I'll touch a bit more on this later because there's a bit of a case study with this particular image. We've got our automatic band detection. Obviously that's configurable to work with this image. Molecular weight ladders, dendrogram creation, which isn't in ImageLab. Normalization functions including multichannel image normalization, so total lane protein normalization, things like that. Quantity calibration, and we can obviously support our automatic quantification from ladder, and our PDF report exports, CSV exports, things like that. So on the background subtraction, which is a really, this is a really good example of it. If we come back to the setup page, we can see here that actually the background levels in this image, they vary significantly based on which lane you're analyzing. So you can see the edges of the image here up to about the third of the image on either side have really high background levels. But when we come to the middle of the image, so I guess lanes 6 to about 10, they have a very low background level. So actually, if we wanted to apply a blanket background subtraction, we would have to set it very high to try and remove the background at the edges of the gel, but we would also potentially lose information within the middle of the gel. Now, ImageLab only allows you to set a uniform background subtraction level across every single lane, which, as I mentioned, would be too strong for the middle, but maybe not strong enough for the edges. So you, the user, are forced to optimize for either lanes in the middle or lanes at the edges. Otherwise, your data is going to be compromised. So what we can do within Phoretix 1D is actually we can set different background subtraction methods and strengths, so sensitivities, on a lane by lane basis. So if I select multiple lanes here and I start managing my background subtraction, I can still apply a background subtraction setting to the whole gel if I want, but I can also change it depending on which images, which lanes I have active, basically ticked on this menu or on view here. So if I grab, let's make this very extreme. So if I grab lane 2 and let's say lane 14, I turn off all the others. We can see here To try and remove some of this background, actually the background subtraction's done a pretty good job there. If we wanted to set this low enough that we can still see some of these peaks, we're actually still introducing some background into the lane above. So what we want to be able to do is get nice clear peaks and clear readouts where we're not removing any of our sample data, but we are removing background from this lane here without subtracting too much from lane 14 and starting to take from our bands. So what I can do is just go to lane 2. I can just look at this. I can set this to be where I want. So we want this a little bit higher because we want to remove these sections here which we may consider background. So if I set this high enough that we start to remove some of that between our bands, and then I turn, so that's a background subtraction level of 6. If I come down and set lane 14 to 6, we can see that actually that background setting starts to really bite into the measurements that we're getting from our bands. Like we're subtracting all of this. We can see that here. We're subtracting all of this data from our experiment and a huge amount of lane, band volume from this band as well. So the ability to be able to have this per lane background subtraction or different methods for background subtraction. So if you've got very dirty lanes or lots and lots of bands that are overlapping, you might want to use lane edge average for those lanes, but you may want to stick with rolling ball with other lanes. We fully support that, of course. That's within our Phoretix 1D software. Also, if we wanted to try and correct for any of the smiling in this gel, so if we come back to the image view, we can see that there is a lot of smiling in this gel. This obviously occurred during gel warping during the electrophoresis process. We can use our molecular weight markers, and I've got a more in-depth video about how to correct for this, but we can use our molecular weight markers to accommodate for that warping. Probably pick a better lane than that. So if we apply a ladder to both ends of our experiment, I don't know which ladder was used for this image, so I can't pick an appropriate one, but you can see that our yellow lines would start to line up and they would accommodate those measurements for the different bands that we're looking at. So you can still get accurate results. There's Bio-Rad one there. We can still get accurate results for our analysis. Let's remove those bands there. We can still get accurate analysis for our molecular weight markers and for our bands on our image, even when it's smiling, by using those two different molecular weights ladders as anchors and accommodating for the differential across the image. So that's the feature that I really wanted to show off today. I've got more videos on our YouTube channel if you go through the Phoretix 1D playlist about all the different advanced features that we've got here. But by doing this, we've removed a significant barrier from people using Bio-Rad equipment, thinking they may be locked into using the image lab analysis software with that equipment, allowing users to have a choice. As part of that choice, you can obviously get a free trial of our Phoretix 1D software. Check out the description for that free trial link to be able to try it on your own .scn files, your own Bio-Rad export files, and see what you think. But yeah, by introducing this feature within our Phoretix 1D software, it means that you don't need to change the equipment that you've already got in your lab, the equipment that you may be very comfortable with, but you do have more options for the analysis of your images by using Phoretix 1D. Please let me know in the comments if there's anything you'd like adding to Phoretix 1D. We're constantly improving the software, constantly adding new features, and yeah, go to the website, try a free trial, try it out on your current .scn images, and see what you think.